Large language models, or LLMs, are powerful AI systems trained on vast amounts of data from the internet, including web pages and user-generated content. However, this training process often leads to these models absorbing sensitive information, such as personal data or copyrighted material, which raises serious ethical, social, and legal concerns. Principles like the right to be forgotten emphasize the need to remove such unauthorized data from these models without having to rebuild them from scratch. In this research paper titled GRAIL, Gradient-Based Adaptive Unlearning for Privacy and Copyright in LLMs, authors Kun-Woo Kim, Ji-Hoon Park, Ju-Min Han, and Seong-Won Lee from Korea University explore a new approach to address these issues. They highlight that retraining an entire LLM from the ground up is not only extremely expensive and time-consuming but also impractical, especially since reconstructing the original training dataset is nearly impossible. To solve this, the researchers focus on machine unlearning, a technique designed to selectively erase specific knowledge from pre-trained models. The main challenge here is to remove only the targeted information while keeping the rest of the model's knowledge intact, so it doesn't lose its overall performance on general tasks. Existing unlearning methods often fall short because they don't handle multi-domain scenarios effectively. For instance, knowledge related to privacy and copyright can overlap in the model's parameters, meaning that removing one type of information might accidentally delete or corrupt another. This leads to excessive knowledge removal or degraded model performance. The paper points out that laws and legal principles, such as those governing privacy and copyright, require a clear distinction between what needs to be unlearned and what should be retained. Unfortunately, many current approaches don't make this distinction precise enough, sometimes removing information that's still necessary. To overcome these limitations, the authors introduce GRAIL, which stands for Gradient-Based Adaptive Unlearning. This is a novel framework specifically designed for multi-domain unlearning. GRAIL uses gradient information from multiple domains to accurately separate the unlearning scope, the parts of the model that need to forget specific knowledge, from the retention scope, which is the knowledge that must be preserved. At its core, GRAIL employs an adaptive parameter-wise localization strategy. This means it examines the model's parameters on an individual basis, rather than treating entire layers or sections as a whole. By doing so, it can selectively adjust or remove only the targeted knowledge while protecting critical parameters that are shared across domains. For example, imagine the model has overlapping representations where privacy and copyright information intersect. Traditional methods might corrupt these shared areas, leading to unintended losses. In contrast, GRAIL adaptively identifies and unlearns only the precise elements needed, preserving the overlapping parts that are essential for other functions. The paper includes a figure that illustrates this difference. In traditional unlearning, fixed boundaries within the model's layers are used, which often overlook the specific scopes for privacy and copyright. As a result, when trying to unlearn one type of knowledge after another, important information gets damaged. With GRAIL, the process is more refined. It adaptively unlearns the necessary parts while ensuring that the retention scopes for both privacy and copyright remain intact, even in overlapping representations. The researchers conducted experiments on unlearning benchmarks to evaluate GRAIL's effectiveness. Their results show that GRAIL achieves unlearning success comparable to existing approaches, meaning it successfully removes the targeted knowledge. However, it outperforms them in knowledge retention, with up to 17% stronger retention success compared to the previous state-of-the-art method. This demonstrates that GRAIL can handle the delicate balance between forgetting and remembering without compromising the model's overall capabilities. This work is supported by various grants from the Institute of Information and Communications Technology Planning and Evaluation in Korea, focusing on areas like artificial intelligence graduate programs and AI research hubs. Seong-Won Lee is noted as the corresponding author. In the introduction, the paper delves deeper into how LLMs, as referenced in studies from sources like those in references 1 through 3, inadvertently learn sensitive data during training. It stresses the importance of machine unlearning as a more efficient alternative to full retraining, citing works from references 5 through 12. The index terms provided, large language models, machine unlearning, ethical considerations, and safety, underscore the broader implications of this research. By establishing a new paradigm, GRAIL helps in effectively managing and regulating sensitive information in large-scale pre-trained language models, paving the way for more ethical and safer AI deployments. Overall, this framework represents a significant step forward in addressing the intertwined challenges of privacy and copyright in AI, ensuring that models can adapt dynamically to legal and ethical requirements without sacrificing performance.